Hello, welcome back. Today, we're going to take a quick look at logarithms, introduce them. So, what is a logarithm? Why does it exist? A logarithm exists as an inverse function to exponents. So, an exponent is a set of instructions. Take this number, multiply it by itself this many times. A logarithm is a tool that allows you to find the value when x is the exponent, when the number of times you're multiplying something by itself is the unknown. So a logarithm asks the question, how many times do I raise this? How many times do I multiply this base times itself to get the number I'm looking for? All right, let's take a look at that. Okay, so over on the right-hand side of the paper, we have the exponential form. Base b raised to some unknown equals a number, b to the y equals x. The logarithmic form of that exponential expression goes log base b of x equals y. It asks the question, b raised to what power gets me x? Whereas the exponential form is an instruction. Raise b to this power to get x. So again, let's look at how these go together. So first, the way you say this, log base b of x equals y. The way you say this one, b to the y equals x. And so here's how they interact. To get from logarithmic form to exponential form, okay, the b is your base, so log base b. So we say b to the y equals x. B to the y equals x. B to the y equals x. So to get from exponential form to logarithmic, b is our base. So log base b of x equals y. All right, so now let's take a look at a couple of rules and let's explore why they're rules. So we have the zero rule, which says that the log base b of 1 will always equal 0. Well, let's take log base b of 1 and flip it over to its exponential form. So again, that's b to the 0 equals 1, b to the 0 equals 1. And you can see that that's true. Anything raised to the 0 equals 1, which is why it is a rule that the log base anything of 1 is always going to equal 0. The identity rule tells us that the log base b of b equals 1. Well, again, let's flip that to exponential. B to the 1 equals b. And we can see that that is true. Any base raised to the 1 will still equal itself. So the log base b of b is always going to equal 1. And then a final fact to know. Sometimes you see log written and it has no base. In that case, there is an implied base of 10. So log of b is asking the question, 10 raised to the what will get you this number. And then that is also the logarithm that is in your calculator. So when you just see log in your calculator, that is log base 10. All right, let's take a look at some applications here. So our first question here, log base 3 of 81. So let's put a variable in there. Let's flip it to exponential form. 3 to the x equals 81. And we know that 81 is 3 to the 4th, which means that x equals 4. So log base 3 of 81 equals 4. Let's do it again here. Log base 2 of 8. So that's saying 2 to the what equals 8. 2 to the what equals 8. 8 we know is 2 to the third. So the answer to our question, log base 2 of 8 equals 3. All right, let's do it again. Log base 5 of 125. 5 to the what equals 125. 5 to the x equals 125. We know 125 is 5 cubed. And so we know that x equals 3. So log base 5 of 125 equals 3. So that's our first 3 examples of evaluating logarithms. Now let's take a look over here where our x is in some weirder places. Log base 2 of x equals 3. Well, again, let's switch that to exponential. 2 to the 3 equals x. And 2 to the 3 is 8. So x equals 8. Let's do it again here. Log base x of 16 equals 4. X to the 4 equals 16. What to the 4th equals 16? 2 to the 4th equals 16. And then finally, log base 5 of x equals 2. 5 to the 2 equals x. And so that's to say that in this case, our x is 25. So that is 3 examples of evaluating logarithms and 3 examples of converting from logarithmic form to exponential form in order to solve. So you can go back and forth between log form and exponent form depending on what's needed. And so one final time, let's just take a look at that. Exponential form says b to the y equals x. The logarithmic version of that is log base b of x equals y, or b to the y equals x. And so then over here, if we were going to convert it, it's log base b of x equals y. All right, that was your first taste of logarithms. They are actually a really powerful tool. They let you solve. They give you a mathematical action to take when your variable is the exponent, right? When your exponent is a number, we know how to keep solving. If it's, to the third, you would take the third root. But if it's to the x, you can't take the x root, but you can take the log, which then allows you to convert your exponent into multiplication. And to find out how to do that, watch my next video, which investigates something called the power rule. All right, watch this video a couple times, play with it, make up some of your own problems, then go check out that next video that has the product rule, the quotient rule, and the power rule. And as always, keep mathing.